Hello and welcome to another installation in this online chemistry textbook. Today we're going to be covering another chemistry essential, that is metallic bonding. To begin, we're going to be talking about delocalized electrons, which form an electron C model. This electron C model is what is responsible for metals' ductility, low volatility, conductivity, and malleability. Here we see an example of a metallic bond, in which delocalized electrons are floating around the positive protons of metal ions. Now we are going to be talking about the characteristics that metals have due to their delocalized electrons and electron C model. The first being conductivity. Conductivity is the ability of a metal to conduct heat and electricity. Now, as we know, heat and electricity are transferred through the flow of electrons. Therefore, by having a sea of delocalized electrons, it makes it very easy for electricity and heat to be passed through metallic bonds. Next, we're going to be talking about malleability, or the ability of metal to be shaped and formed into different sizes. Malleability is possible because when the metal is heated, its atoms are able to slide past one another due to its free-flowing electrons. Next, we're going to be talking about ductility. Ductility is the ability of a metal to be stretched out and pulled into wires without snapping. Ductility in metals is possible because atoms are free to slide past one another rather than getting stuck in a specific shape. This again relates back to the sea of electrons model and what allows metals to have many of their characteristics. Finally, the last trait we're going to be talking about is low volatility. In metallic bonds, there is a strong force of attraction between all of the protons floating around and all of the delocalized electrons. This force of attraction results in the low volatility that most metals possess. Here, we see an example of a metallic bond in which the protons are aligned in a grid formation while the delocalized electrons are floating around unorganized around the protons. Here, we see another example of a metallic bond in which the protons are their own individual circles while the electrons are floating around interacting with each proton individually. The most important thing to remember about metallic bonding is that each metallic bond contains delocalized electrons which form an electron C model. This electron C model explains why metals have the characteristics they do and explains how metallic bonding is unique from all other forms of bonding. This is only a brief introduction into the complex world of metallic bonding. Thank you for watching, and I hope you learned something about chemistry.